Good morning to all. The first unit, the important topic is thermal stresses and strain. When a material is free to expand or contract due to the exchange in temperature, no stress and strain will be developed in the material. But when the material is rigidly fixed at the both ends, the changing length is prevented. Due to changing the temperature, stress will be developed in the material. Such stresses is known as thermal stresses and the corresponding strain is known as thermal strain. In other words, thermal stress is stress developed in the material due to change in temperature. How we can determine the thermal stresses and strain? The change in temperature of a rigidly fixed bar is given below. The original length is L and due to the deformation, the change in length is alpha into T into L. The compressive stress, strain or thermal strain is equal to decrease in length or increase in length divided by original length. Therefore, alpha into TL divided by original length plus deformation length. So the thermal strain is nothing but alpha into T. Alpha is the coefficient of thermal expansion. T is the temperature. The thermal stress is equal to thermal strain into Young's modulus. We already know the thermal stress into E, which gives the thermal stresses. Next important topic is thermal stresses in composite bars. Okay. For example, a bar consists of brass and steel. It is called composite members of different materials which are joined together. The following figure shows the composite bars consisting of brass and steel, which are subjected to temperature variations due to the different coefficient of linear expansion. The two materials expand or contract by different amount. When the ends of the bars are rigidly fixed, then the composite sections as a whole will expand or contract. Since the linear expansion of brass is more than that of steel, the brass will expand more than the steel. So, the actual expansion of the composite bars will be less than that of brass. Therefore, brass will be subjected to compressive stress, whereas the steel will be subjected to tensile stress. The stress in the brass is equal to load on the brass divided by area of the brass. But the load acting on the brass is equal to load acting on the steel. We already seen in the second portion, the load is equal to stress into area of the material. By using this expression, we can find out the thermal stresses of steel and brass. Alpha ST plus sigma S by E is equal to alpha of brass T minus sigma B divided by EB. This numerical problem, we can directly substitute the derived formula and we can find out the different stresses developed in the composite bars.